Hello students, in this video I'm going to explain about parallel flow heat exchanger and counterflow heat exchanger, uh, the steps to solve simple problem of heat exchanger. First, parallel flow heat exchanger. Uh, First I will tell you the notations which I considered based on heat transfer data handbook. Hot fluid entry from left side it is T1. Hot fluid outlet or hot fluid exit is capital T2. So hot fluid it is capital T1 and capital T2 are the temperatures at entry and exit, and small T1 and small T2 are the temperature of cold fluid at the entry and exit. In parallel flow heat exchanger, cold fluid enters from this left side, and it just uh, pass in this way, and its exit is in the right side, and in the same direction hot fluid direction is also in the same direction as of cold fluid. So both will pass through the heat exchanger in parallel in the same direction. That's why it's called as parallel flow heat exchanger. So it also shows the same. So this is inner tube and this is the outer tube. In inner tube, hot fluid is flowing, and in the outer tube cold fluid is flowing. So here I explain the notations. This is a graphical representation of uh, parallel flow heat exchanger, I mean temperature changes. So this line indicates hot fluid temperature change, and this line indicates cold fluid temperature change. So hot fluid, the temperature decreases as it passes through the heat exchanger, and cold fluid temperature increases by absorbing the hot fluid, the heat from the hot fluid. And you can say capital T1 here, hot fluid entry, and this is capital T2, hot fluid exit. And from the left hand side itself, the small T1, cold fluid entry, and small T2, cold fluid exit. We can observe here the temperature difference at the entry is more, and at the exit is it's very less, almost near to uh, the hot fluid outlet temperature. So that much temperature will be getting, and the difference between a hot fluid entry and cold fluid entry temperature is delta T1, and hot fluid exit and cold fluid exit temperature is delta T2. So here I have given that one. This is the formula to find out heat transfer rate Q, or uh, overall heat transfer coefficient U, area, surface area of inner tube, and LMTD. Q equal to U into LMTD. So this LMTD will find out with the help of this formula. LMTD equal to delta T1 minus delta T2 divided by ln delta T1 by delta T2. Here the delta T1, delta T2, I already explained. Delta T1 equal to capital T1 minus small t1. Delta T2 equal to capital T2 minus small t2. For heat transfer rate Q, there is one more equation. I mean, it's for hot fluid, and the one another equation for cold fluid separately. And this Q is for heat exchanger. This Q is heat exchanger. Q equal to mHCpH into capital T1 minus capital T2 for hot fluid. Q equal to mCCpC, small t2 minus small t1. It's for cold fluid. Here mH is mass flow rate of hot fluid in kg per second. MC is mass flow rate of cold fluid in kg per second. And Cph is specific heat of hot fluid in kilojoule per kg Kelvin. Cpc is specific heat of cold fluid in kilojoule per kg Kelvin. One more heat exchanger is counterflow heat exchanger. Here you can see this cold fluid entries from left side to right side, and hot fluid flow from right to left. So the direction of flow is opposite in this counterflow heat exchanger. Cold fluid flows in one direction, and in the opposite direction there is a hot fluid flow. So because of this, the temperature difference between hot and cold fluid will be same throughout the heat exchanger. So that will increase the effectiveness of the heat exchanger. As we know, for the heat transfer rate, temperature difference is one of the most important parameter. So based on that, this is called as effective heat exchanger. And here also the same thing, it's showing like in inner tube hot fluid is flowing in the one direction, and in the outer tube the cold fluid is flowing in the other direction. And this is graphical representation, the temperature change. So this line indicates hot fluid temperature change, and this line indicates cold fluid temperature change. Just observe the arrow mark shown. So this is entry to exit in this way, T1, capital T1 to capital T2 hot fluid temperature, and you can see the direction is opposite in this cold fluid. So small T1 to small T2. The difference, so here delta T1, delta T2, we have given the notation, but the difference will be same. It's different compared to parallel flow heat exchanger. Delta T1 is equal to capital T1 minus small t2, delta T2 equal to capital T2 minus small t1. So you need to refer this graphical representation of temperature while writing delta T1 and delta T2. So I'll explain the steps in solving simple problem of a heat exchanger. First, you need to write in step 1, write the given data, all the temperatures, mass flow rate, and specific heat, whatever the given data is there in the question, so that you need to write. Second, find the unknown temperature of T1, T2, small t1, small t2 by using Q equal to mHCpH, T1 minus T2 equal to mccpc T2, small t2 minus small t1. So here in this problem, LMTD problem, he will give you any three temperatures. Out of this, any three temperatures will be given. For example, hot fluid entry, hot fluid exit, or cold fluid entry will be given. So cold fluid exit temperature you need to find. It's just an example. Any temperatures he may give, but three temperatures will be given. And what you need to do is just equate these equations, mHCpH into capital T1 minus capital T2 equal to mccpc into small t2 minus small t1. Out of this, mH will be given, cph will be known, mccpc will be known, any three temperatures will be known, so only one unknown temperature will be here. And one more very important thing is, if the fluid is water, and its CPC or specific heat is not given, CP is not given, then assume it as 4.184 kilojoule per kg Kelvin. So that's very important. And step 3, you calculate Q by using any one equation given below. Like this Q can be calculated either by using Q equal to mccpc into small t2 minus small t1, or Q equal to mHCpH into capital T1 minus capital T2. So very important is, see, while writing the temperatures for cold fluid, it's small t2 minus small t1, and for hot fluid, capital T1 minus T2. So this is the difference of the temperature. And step 4 is very important. Calculate LMTD. Um, so for parallel, actually the LMTD equation is same for both parallel and counterflow heat exchangers. That is LMTD equal to delta T1 minus delta T2 divided by ln of delta T1 minus delta T1 divided by delta T2. But uh, delta T1 and delta T2 changes depending on whether it's a parallel flow or counterflow. For parallel flow, delta T1 equal to, you just refer this diagram, capital T1 minus small t1, delta T1 equal to, and delta T2 equal to capital T2 minus small t2. For counterflow, you can see the diagram also. Delta T1 equal to capital T1 minus small t2, and delta T2 equal to capital T2 minus small t1. So like this it will be written. Only this is the difference while writing parallel flow and counterflow heat exchangers. So step 5, last step is calculate the unknown parameter from the below equation. So Q equal to UA LMTD. Here he may ask you to find out overall heat transfer coefficient, area, or area or overall heat transfer coefficient will be asked. And in that also, in area also, he may ask find the diameter of the tube or find the length of the tube. So like that he will ask you in the question. So once if he ask you like diameter or length, first you find out the, you will be knowing these values like Q, U, and LMTD. Only area you need to find first. Then after finding area, then find out L or D, which one is unknown, that you need to find out. So this equation may be used to find out overall heat transfer coefficient, area, or D naught, the outer surface area of inner tube, or length of the tube. So this is about the steps involved in solving simple problem of heat exchanger and this parallel and counterflow heat exchangers.